Caring for the environment is important to us all and a responsibility which we all share. By working together, we can ensure that we play our part in every one of our factories throughout Europe. This programme discusses some of the environmental issues involved in food manufacturing, talks about some of the initiatives we're developing, and explains those areas where you can help. The two topics we'll be covering are managing industrial waste and protecting the ozone layer. In both, we will also be considering energy conservation. Let's start by discussing the management of industrial waste. We use large amounts of water for cooling, generating steam for heating, and for washing raw materials like vegetables. Most of our water usage, however, is for cleaning equipment, walls and floors to achieve the very high standards of hygiene which we demand in our factories. As a result, the water becomes contaminated with food and detergent residues, which all end up as effluent in the drainage system. As with houses, there are two types of drains: stormwater drains and effluent drains. Stormwater drains carry rainwater away from roofs and roadways. This water isn't treated and it goes directly into our river systems. Effluent must, however, go through treatment plants, which purify the water before discharging it back into the river. Cities and towns will operate these plants to process their sewage. Large manufacturers like us frequently operate their own effluent treatment plants. In fact, we operate 11 large effluent plants, each one of which would be capable of treating the waste of a town of 70,000 people or more. So why is it important to treat the waste from food factories before we put it back into the river? Although none of it contains toxic chemicals like lead or mercury, food waste does contain sugars and starches, proteins and fats. Naturally occurring microbes or bacteria which live in the river can feed on and digest these substances. To do this, they use the oxygen dissolved in the river. Essentially, bacteria need a food source, oxygen and moisture to thrive, just like human beings. If we were to discharge effluent into the river, all the oxygen would be used up as the effluent is digested. This is the very oxygen that the fish and plant life need to live. In short, it would cause the river to die. The amount of oxygen used by the microbes can give us a measure of how strong the effluent is. This is called the BOD, or biochemical oxygen demand. The higher the BOD, the stronger the effluent. To discharge our effluent into the river, we must comply with a certain maximum level of BOD. Let's look at how effluent is treated. Firstly, the flow is balanced because the discharges from the factory are not constant. Solid matter is removed using sieves. Then most of the fat is removed. In modern plants, this is done by a process known as dissolved air flotation. Bubbles of air pass through the liquid, carrying the fat to the surface where it can be removed mechanically. The effluent then passes into a lagoon, ditch or biological filter plant where the main treatment takes place. This process mimics that which naturally occurs in the river. It uses microbes similar to those found in nature to digest the effluent and make it harmless. The lagoon must be provided with oxygen. Where air compressors are used, the cost of electricity each year can be as much as £150,000 for each plant. By the time the effluent has passed through the biological process, the sludge separated and fine particles filtered out, it's pure and can safely be discharged into the river. We are continually improving our effluent plants and have spent £6 million since 1987 on upgrading. Not only will this ensure we meet our legal requirements, it's also included landscaping, noise reduction and eliminating smells to improve the overall environmental impact. To protect the environment, we must prepare for any problems that could occur. A working group has looked at 4 main areas of concern. First of all, what happens if the electricity supply fails? Without electricity, the vital oxygen cannot be pumped into the lagoon, and the bacteria would start to die. This would be very serious, as it would take a considerable time to nurse the bacteria from sickness back into full health so that they could do their job properly. To prevent this, we have emergency electrical generators. Secondly, what happens if the plant breaks down? Critical spare parts are always available for our treatment plants and are held at strategic factories. The factory engineers can then get to work immediately. Third, what happens if the plant is overloaded? Major initiatives to control wastage have reduced the risks. In addition, 24-hour emergency procedures are in place. Fourth, and what about the risk of spillages into stormwater drains? The sad fact is that the two most serious pollution incidents which have occurred in the company's history were caused by accidental spillages in the yard areas which went down stormwater drains and directly into the river. To reduce this risk, we are colour-coding all our manhole covers so that it can be easily seen whether a drain is a stormwater or effluent drain. We're also putting bunds or short walls around oil tanks and chemical stores to contain any spillages. In cases where our effluent is treated by the water companies, the principles are the same, and we are charged according to the volume and strength biochemical oxygen demand of the effluent. The cost of treating our effluent is almost entirely due to the cost of electricity. If we're really serious about caring for the environment, we should also look at what we can do to reduce this electrical consumption and conserve fossil fuels. We need to reduce the volume and strength of our effluent. If we're to be successful, we need the ideas from those working in the factory. We need your help. These can be promoted through the wastage or effluent control group which operates on site. To develop your action plan, you will need some further information. This has been largely due to the ideas of our factory staff. Through teamwork and attention to details, you can help the environment. Why should we be concerned about the ozone layer? As everyone is aware, a layer of ozone gas exists in the upper atmosphere. This layer filters out much of the ultraviolet rays from the sun. Without this ozone layer, these harmful rays would reach the Earth, damaging plant and animal life. Why is the ozone layer under threat? It's due to CFCs, which are also gases. They are widely used in domestic refrigerators and industrial refrigeration equipment. This gas is used in some aerosols and in making certain synthetic foams for insulation, furniture, packaging and other purposes. If contained, CFCs are harmless, but if they're allowed to escape into the air, they destroy the ozone layer. This has been happening and has resulted in a thinning of the ozone layer. Certain CFCs are worse than others. As an example, CFC 12 has 20 times the effect of CFC 22. What about CFCs in our refrigeration plants? Less than 7% of our refrigeration capacity is provided by the more harmful CFC 12, exclusively in older cold stores and on vehicles, the balance being provided by equipment using CFC 22 or ammonia. Ammonia is the oldest refrigerant, and it has no effect on the ozone layer. In fact, over 2/3 of our refrigeration comes from plants which use ammonia. But ammonia does have certain disadvantages. Firstly, it's a flammable gas which can ignite. In comparison, CFCs are non-flammable. Secondly, the ammonia gas is toxic. However, low levels of ammonia are easily detected by its characteristic smell. In comparison, CFCs are odourless and much less harmful. Because of the safety risk, ammonia refrigeration plants can only be operated and maintained by trained staff. Therefore, it's generally not practical to use them on vehicles or for cold stores at depots. What can we do to CFC units in the future? A new generation of ozone-friendly materials are being produced and should become available in the early 1990s. Our refrigeration engineers are currently investigating whether we can convert our existing plants to use these new materials. Equipment using CFC 12 cannot easily be converted. As our plants running on CFC12 are older, our strategy will be to replace this equipment as it nears the end of its working life. Our biggest challenge is the equipment which we use on our vehicles. Traditionally, all equipment which has been used in the chilled transport industry has operated on CFC12. Units are being developed to use ozone-friendly refrigerants, and we're cooperating with refrigeration manufacturers by offering our facilities to trial any new equipment on their behalf. The practical steps which must be taken to stop CFCs escaping to the atmosphere. It also explains the procedures which must be used when CFC refrigerants need to be removed from the equipment. They're drained into special canisters for collection and a recovery service. By using this code, engineers, maintenance staff and contractors will help protect the ozone layer. We all have a responsibility, not just the engineers. We can all help by not wasting cold air. Chilled air is heavier than warm air. If cold store or vehicle doors are opened, it flows out very quickly. Loss of cold air not only affects our ability to keep products chilled, it also means we have to run our refrigeration plants harder, using more electricity to operate the plant, which in turn is not helping our contribution to energy conservation. Through understanding some of the technical issues involved in food manufacture, we can all help to protect the environment. We ask that you will all look at your own area and think what can be done to help. After all, it's not only our future, but that of generations to come.